In this class, I am going to explain about short circuit parameters. Short circuit parameters or the another name for these short circuit parameters is Y parameters or admittance parameters. Admittance parameters. So, in this concept, these two-port network, let me draw the two-port network here. So, this is the two-port network. In this two-port network, 4 variables will be present here. V2, it is I2, it is V1 and this is I1. This is 1, 1 dash, 2, 2 dash. So, this is the input port and it is output port. Here, among these 4 variables, 2 variables can be represented with another, that means 2 variables can be expressed in terms of another 2 variables. So, in this short circuit parameters, this I1, I2, these variables can be expressed in terms of V1 and V2. That means this I1 and I2 are the functions of this V1 and V2. So, these are the independent variables. V1 and V2 are the independent variables. I1 and I2 are the dependent variables which depends upon this V1 and V2. How these I1 and I2 depends upon this V1 and V2, let me explain with the vector matrix form. So, it is I1 and it is I2. So, it is Y11, Y12, Y21, Y22. Here it is V1 and V2. So, this matrix represents short circuit parameters. Y11, Y12, Y21, Y22 are the short circuit parameters. Now, let me represent these vector matrix form into equations, equation representation. I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. So, this is how we can represent with this equation representation. Okay. Now, this Y11 and this that means how to calculate these Y parameters here. First, short circuit the output port. Short circuit the output port or the port 2 means short circuiting the port 2 means V2 should be equal to 0. The voltage of the short circuit is 0 and if I substitute this V2 is equal to 0 in these equations, then I will get I1 is equal to Y11 V1, I2 is equal to Y21 V1 and this Y11 is equal to I1 by V1 and it is at V2 is equal to 0 and this Y21 can be calculated using this formula I2 by V1 when V2 is equal to 0. This Y11 is named as, it is driving point input admittance, driving point input admittance. driving point input admittance, or simply it is short circuit input admittance. This Y21 can be named as it is I2 by V1. So it is transfer admittance with port 2 short circuited. Here also with port 2 short circuited. Next, or this can also be named as this Y21 is equal to I2 by V1 can also be named as it is short circuit. It is forward. If it is I2 by V1, then that is forward transfer admittance. If it is I1 by V2, then that is reverse transfer admittance. So it is I2 by V1. So it is forward short circuit forward transfer admittance. Next. So if I short this port 2, I am able to calculate the values of this Y11, Y21. Second one is, if port 1 short circuited, then that means if V1 is equal to 0, then if I substitute this V1 is equal to 0 in these equations, then I will get I1 is equal to Y12 into V2 and I2 is equal to Y22 into V2. From this I can calculate or I can measure this Y12 is equal to I1 by V2 at V1 is equal to 0 and Y22 is equal to I2 by V2 when V1 is equal to 0. This is named as it is I1 by V2. I already told you it is it is transfer admittance with port 1 short circuited, or it is short circuit reverse transfer admittance. So this is the name for this Y12, and this Y22 it is driving point output admittance with port 1 open circuited, or it is short circuit output admittance. So these short circuit parameters or Y parameters can be obtained using these formulas. Now let me explain the equivalent circuit of the two-port network in terms of Y parameters. So equivalent circuit of two-port network in terms of Y parameters. So how to draw this equivalent circuit of this two-port network in terms of Y parameters? we know that I1 is equal to, so from this equation, y11 v1 plus y12 v2, I1 is equal to y11 v1 plus y12 v2, and this I2 is equal to y21 v1 plus y22 v2. Now this is a two-port network. V1 it is V2, I2 it is I1, two-port network. I need to represent this two-port network with its equivalent circuit in terms of Y parameters. So first let me draw its equivalent circuit. Here it is plus and minus, it is V1 and it is I1. Here also it is plus and minus, it is V2 and the current flowing through this is I2. Now I want to represent this two-port network in terms of Y parameters. So here this current is equal to this current, it is a current equation. I is equal to Vy or Yv, it is a current. So now I1 is equal to y11 v1. I am going to represent it as, this is one current, so this current is y11 v1. So I am representing this one as y11. Next another current, this is another current, so this one I can represent this current depends upon this voltage. So I am indicating with a dependent source here, and the direction of the current is like this, and the value of this current source is y12 v2. Now this I1 is equal to this current is the voltage across this element into the admittance. Voltage across this element is V1 into admittance is y11. So V1 into y11. So this is this current plus this current y12 into V2. Similarly, for this equation also, I2 is equal to this current is equal to this current plus this current. So here this is y22 V2. So now let me draw this y22. So this is y22 and the voltage across this one is this voltage V2. The current flowing through this is V2 into y22. So this current I obtained now. Now I need to add this current with this current. So this current depends upon this voltage. So I need to draw the dependent source here, dependent current source, and the direction of the current source is this direction, and the value of this current source is y21 into V1. So it is y21 into V1. Now I need to add these two things here. So this is the equivalent circuit representation of a two-port network in terms of Y parameters. So this network satisfies these equations here. So it is an equivalent circuit of two-port network in terms of Y parameters. Now let me derive the condition for reciprocity. Condition for reciprocity. Condition for reciprocity in terms of Y parameters. So let me draw the two-port network here. This is a two-port network. V1 plus and minus, it is V2, it is I2, it is I1. It is a two-port network. So according to the condition of reciprocity theorem, the network is said to be reciprocal if the ratio of response or the ratio of excitation at one port to the response at the other port should be equal to the ratio of excitation to the response, the ratio of excitation to the response at one port, let me write here, the network is said to be reciprocal if the ratio of excitation at one port to the response at the other port should be equal even when the excitation and response are interchanged. Excitation and response are interchanged. With one of the port should be short circuited where the response is measured or calculated. So the network is said to be reciprocal if the ratio of excitation, let me take the excitation here for this network, it is the excitation I am taking, 2-port network. I am taking the excitation here, it is plus and minus, V1 is equal to Vs, and the current here is I1, and the response I am calculating at the port 2, it is 1 dash, it is 2 dash, and where we are calculating the response, that should be short circuited. So it should be short circuited, and this is I2 dash. So the excitation to the response, the excitation at one port to the response at the other port ratio, that is Vs by I2 dash, should be equal even when the excitation and response are interchanged. That means even if I change the excitation and response here, it is 2-port network, now I am giving the excitation here, just I need to interchange this excitation and response. This is I2 and this is I1. The excitation, it is this one is excitation, this one is response here. I am calculating the response here. So just I am interchanging this excitation and response. What I mean to say here is, according to the reciprocity theorem, this Vs by I2 dash should be equal to this Vs by I1 dash. The ratio of excitation at one port to the response at the other port should be equal even when the excitation and response are interchanged. That means Vs by I2 dash is equal to Vs by I1 dash. From that I am able to find the condition for reciprocity in terms of this y parameters. So let me write these equations. I1 is equal to y11 v1 plus y12 v2, and I2 is equal to y21 v1 plus y22 v2. So from this diagram, I can say that V1 is equal to Vs and I2 is equal to minus I2 dash, because these two are in opposite direction. So I2 is equal to I2 dash minus I2 dash, and V2 should be equal to 0 since it is a short circuited. Vt is equal to 0. Now let me substitute these values in these expressions. Now I1 is equal to Y11 Vs, in place of V1 it is Vs. V2 should be equal to 0, so now it is plus 0. From this Vs by this is I1 is equal to Y11 Vs. What I need to calculate here, Vs by I2 dash. So I am going to calculate from this expression. So if I substitute these values in this expression, I2 should be equal to minus I2 dash. Minus I2 dash is equal to Y21 into V1, in place of V1 it is Vs. If V2 is equal to 0, then it should be equal to 0. Now this Vs by I2 dash, I need to calculate this Vs by I2 dash. So this Vs by I2 dash is equal to, from this, minus Y21. So let me consider this equation as 1. And if I interchange this excitation and response, this is the diagram, and I need to calculate Vs by I1 dash for this circuit. So same expressions here. The conditions are V2 is equal to Vs. Here V2 is equal to Vs, and I1 is equal to minus I1 dash. I1 is equal to minus I1 dash, and V1 is equal to 0. V1 is equal to 0. If I substitute these equations in this, if I substitute these conditions in these expressions, then I1 is equal to minus I1 dash. So minus I1 dash is equal to V1 is equal to 0 and Y1 to Vs. So from this I can calculate this Vs by I1 dash is equal to minus Y12. So it is equation number 2. According to reciprocity theorem, according to reciprocity theorem, the ratio of response to the ratio of excitation to the response is equal even when the response and excitation are interchanged. That is, this one is equal to this one. That is, Vs by I2 dash is equal to Vs by I1 dash. So if I equate this one, minus Y21 is equal to minus Y12. So this minus and this minus will get cancelled. So finally the condition for the reciprocity is Y12 is equal to Y21. So this is the condition for the networks which are reciprocal. Next, let me derive the condition for symmetricity now. Condition for symmetricity. The condition for symmetricity. The networks are said to be the networks or the network is said to be symmetrical if the ratio of voltage to the current or excitation to the response at one port, the ratio of voltage to the current at one port should be equal to the ratio of voltage to the current at the other port, the network is said to be symmetrical if the ratio of voltage to the current or excitation to the response at one port should be equal to the ratio of voltage to the current at the other port, provided one of the port should be open circuited. So this is the condition for symmetricity. Let me explain with the diagram. So this is the two-port network. This is V1, sorry, it is V2, this is I2, this is I1, and this is V1. It is a two-port network. Okay. So in this two-port network, the ratio of voltage to the current or excitation to the response at one port, that is this V1 by I1, should be equal to the ratio of voltage to the current at the other port, that is V2 by I2, provided one of the port should be open circuited. So first diagram I am going to draw. I am going to find here the ratio of excitation to the response at port 1 dash, it is 2 dash. So here the ratio of excitation to the response or voltage to the current at port 1. This is what I am going to calculate here. That is, it is a two-port network, and this is plus and minus. It is V1 is equal to Vs, and this is the current I1, and it should be open circuited. That means this I2 should be equal to 0, and it is plus and minus, it is V2. One of the ports should be open circuited. Okay. Now here I need to find this Vs by I1, the ratio of voltage to the current or ratio of excitation to the response at one port. So here let me write these equations. I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. Now here the conditions here are V1 is equal to Vs and I2 is equal to 0. Substitute here in these expressions and try to calculate this Vs by I1. So V1 is equal to Vs. So if I substitute here, okay, so I1 is equal to Y11 Vs plus Y12 V2. I don't know the value of this V2. I need to express this V2 in terms of this I1 and Vs. So for that I am using this equation here. So I2 is equal to 0. From this, if I substitute this is Y21 into, in place of V1 substitute this Vs plus Y22 V2. Now write this V2 in terms of this Vs.